Hi, my name's Ian and I teach science communication. And today I'm going to tell you why I think science communication is really, really important for geoscientists. Why I think that you should be focusing on science communication and passing the knowledge that you have on clearly and passionately in an interesting way to the wider community. So 3 things before we start. Number 1, I'm not or never have been a geoscientist, but I don't think that really matters here today. I'm here to talk about the principles of science communication, as in communicating your work with the general public. 2, I use the word geoscience here for ease. And by geoscience, I mean geography, and I mean geology, and I mean all the sub-disciplines that exist within your subject. And the 3rd thing is a practical note. And that practical note is in this presentation. You'll see a whole series of QR codes which take you to external sources. If you prefer, you can download the PowerPoint slides and you'll see the full URLs in the notes section. Okay, we're ready to begin. So in my opening, I used the word general public, and I feel that science communication as a discipline is about communicating with the general public. So what do I mean by general public? So I mean the people who have had no teaching of geoscience beyond that present in the national curriculum. And of course, the national curriculum changes year on year, and some may have had less or more than others. So the general public who, through choice or through circumstances, sole knowledge of geoscience comes through the national curriculum. Of course, they are also exposed to geoscience in the world. And one of the most common places that people encounter geoscience, which may not surprise you, is through popular culture. And a great example of that is in film. So here's 2 examples of films which are about geoscience. No, they're not, you may say, but if you go to the Internet Movie Database and search for geoscience or geology films, these are 2 of the top films that come up. And though I've never done any formal poll, I'm pretty confident that people would consider these films around the areas that you're interested in. So on the left-hand side, we have Dante's Peak, which is 1997 film starring Pierce Brosnan and Linda Hamilton. It's a typical action film, so set in a town called Dante's Peak, where they've got a stratovolcano that suddenly erupts and flows down the mountainside, and it's all about their escape from the oncoming volcano. So I'm no geologist, but reading some of the blog information that you can see on the right-hand side here, I'm reliably informed that actually the science or description of the volcano eruption is not too bad. Okay, so there's some good truth in there. Of course, the drama of the film speeds this up to levels which are never seen in nature. One of the kind of fundamental problems that the blogs talk about is that Hawaiian lava flows on Cascade volcanoes are not likely to happen in a single eruption, though of course they may happen over multiple eruptions. You can probably see from the way I'm talking about my words, I don't know. I'm not a geoscientist. So even somebody like myself who does have the privilege of a higher education background, when I'm watching that film, I do not know how to distinguishing fact from reality on that kind of micro nuanced level. The second film you can see on the right is The Core. So The Core is a film that was filmed in 2003. It's got a whole host of actors in it, including Aaron Eckhart and Hilary Swank. And, well, where do I start with this film? Essentially, the Earth's magnetic field starts to collapse because the core of the Earth has stopped moving. And this is causing really, really harmful microwaves to penetrate the Earth's surface. I mean, it's absolutely bonkers. So the team of scientists and NASA pilots drill down to the centre of the Earth. And when they get to the core, they effectively jumpstart it. So you might be thinking this is absolute nonsense. And of course, you are right. There's so many problems with it. Just give you one example. Even not being a geoscientist, I can understand. So, I mean, if the Earth's core stopped moving, which seems ridiculous anyway, I mean, there's so much energy involved. Around 10 to the power of 35 ergs are involved which is roughly 500 million times the nuclear energy of every single nuclear weapon currently present on Earth. So phenomenal amounts of energy. I mean, if the core stopped like it did in a film like that, then that energy would have to go somewhere, and that would vaporize all the oceans in the Earth at least 10 times over. So the microwaves that we're worried about would be irrelevant, would be vaporized from the inside. But there's lots of problems with this film. Some are quite obvious and some are more subtle, and perhaps it's the more subtle ones where we should worry about the perceptions that they create in the general public. So there's just 2 examples of films, and I could give you others. Quake, Armageddon, 2012, Day After Tomorrow, Journey to the Center of the Earth, all fairly popular mainstream Hollywood films that have at heart of part of their narrative something to do with geoscience. So it's not all doom and gloom, because popular culture is actually a really powerful tool for communicating with the public. And I've got 2 examples that you can see here. So on the left, we've got a magazine, which is based on the film The Journey to the Center of the Earth. Well, the Brendan Fraser remake version. It's a really nice kind of comic, which is designed for parents and school teachers to use alongside the film. And geoscientists, researchers and academics were amongst those that contributed the activities. So it's used to help support the education of our younger members of the general public alongside watching something like a film. So a great opening into the discipline. On the right hand side, we've got something completely different. So this is a cover from Earth, Space and Science News. And you can see it's got an article in it called Dig into Geoscience with Minecraft, which you can access by clicking the link here. So this talks about a group of science hunters from Lancaster University. And amongst the many activities that they do is they use the computer game Minecraft, specifically Minecraft Education, to create geographical features to help introduce youngsters, mostly primary and early secondary school pupils, into their subject. So a great way of both educating and also generating that passion and interest in the geoscientists, which presumably you all have. It's a point that shouldn't be overlooked. So sometimes the education component of these resources is the focus. We want to teach stuff about geoscience. But I think, particularly in younger audience, developing that passion for their subject is just as important. So maybe the education value of Minecraft may be small or limited, but if that starts someone on the long journey to becoming a professional geoscientist, then fabulous. Perhaps we can all look back into our roots and what started our love of our own disciplines and subjects. Okay, so that's popular culture. So I've already mentioned the curriculum and, what people do know. I think it's really useful to understand what knowledge of geoscience the general population may have, or at least those who are currently going through the national curriculum in its current format. So on this slide here, the first link here is from the Geological Society and their page on curriculum. And then I've got an actual extract of the national curriculum, just really quickly in case people aren't sure what this is. So the national curriculum is divided into key stages, 1, 2, 3 and 4. 1 and 2 are generally primary school. 3 and 4 are generally secondary school. 4 is the key stage 4 is the one which you'd class as GCSEs. So in key stages 1 to 3, geography is a core subject, so everybody has some geography education. Though the reality is that much of this is mixed together with the general science and chemistry explanations, and you can find full details of that on the links there. Once you get to key stage 4, geography becomes an optional subject, and some take it and some do not. So if you go to the actual national curriculum for key stages 1 to 4, which you can find the link here, you need to go to page 184. You'll see what is actually in the geography curriculum. So to manage your expectation, it's only 4 pages, one of which is the kind of overall aims and the attainment targets. Then the other pages are a breakdown of what's required. And I've just taken a small extract in human and physical geography. So this is by key stage 4. Physical geography, they should describe and understand climate zones, biomes, vegetation belts, rivers, mountains, volcanoes, earthquakes, the water cycle. Human geography, including types of settlement, land use, economic activity, trade links, natural sources of energy, food, minerals and water. So it's the only aspects of human and physical geography somebody who gets to that key stage will have been physically taught by their teachers as part of the curriculum. So you'll probably see all the things that are missing when you look at the national curriculum. Now, of course, you can't cover everything, and that's a separate debate for a separate day. But it is interesting to understand what the kind of education received by the general public will be, which areas they've been educated in and developed an interest in. So far we've looked at the kind of background of information about geoscience that the general public are exposed to, from compulsory education and just one look at the kind of popular culture area and the kind of influences that people receive. What's really important, which hopefully cement the argument that we need to do more work in science communication for geosciences, are attitude surveys. So there's a couple I put here. One is the Public Attitude to Science Survey 2014, which is administered by Ipsos Mori via a charity called the British Science Association, which is all about public attitudes to science communication. The other one is the Welcome Monitor Report, which once again looks at public attitudes to science. You can find the link to the full survey here. But what I'm really interested in is in the bottom right, you can see an infographic, which is the headline news from the 2014 survey. Why 2014? Because they haven't done a new one since then. And we have to be very aware that science is much more at the forefront than it's ever been because of COVID and the prominence that science has played in decision-making process. But if we take a look at that in detail, and I've just taken out 3 extracts, this is what the general public at that time felt about certain areas. And I suspect you're going to be quite shocked by this. So, enthusiasm for science, benefits and harm. 55% of people felt the benefits of science are greater than any harmful effects. So, in the right direction, but only half of people thought that. Science makes our life change too fast. Okay, not many people agree with that. So, okay, that's fine. Science in daily life. It's important to know about science in my daily life. Most people agree. So this should be a catalyst for you to thinking, okay, that's good. I can talk about science then. We tend too much on science and not enough on faith. A third of people do agree with that. And I'm not going to enter this debate now, but I think faith and science have places alongside each other in modern society. Moving on to the green ones on the top right. Public awareness. How well do you feel, if at all, about science and scientific research and developments? 45% of people, less than half, feel that they're well informed. This is slightly higher when you consider the younger age group, but only half of people feel that they know what's going on in science. That's a call to arms to you all. Finding out about scientific research. So if you consider the whole population, most people get their scientific information from the news and other TV, so TV shows and films. They're the 2 most popular cases, with print newspapers just beneath that. Looking at the younger group, news still comes very highly, but social networks, and we could do a whole talk about the spread of false information across such networks. So don't think that the general public are reading scholarly articles. Most of their information comes from TV news, social networks, and TV and film. The last one is just their view of scientists in general. None of these are specific to geoscientists. I should have said that quite clearly. About their values and characters. So most people think they're honest and ethical, but not anywhere near in half. But not many people think that we're good at communicating or interesting. I mean, this is really, really stark and further strengthens the need to refine our communication skills. So you may be thinking, why is he going on and on and on about all this? Why does it matter? Why does it matter if the general public know about geoscience? Well, like I said, I'm not a geoscientist, but you can very easily look around and find big political and social issues where the whole population have opinions or are being asked for their opinions on or need to get together to take action for, which I've got geoscience at their roots. So here I've got fracking and oil and gas extraction as one image. Next, I've got plastic pollution and damage to the environment. Next, I've got disaster response. And this picture is from Fish Lake in Doncaster at the UK floodings a few years ago. So maybe I'm being very trivial about your discipline, but geoscience decisions are at the basis of all these, as well as many other social, political, economic. But they're at the heart of all of them. And we want people to make informed decisions because they affect policy and such decisions. So, yeah, it is absolutely relevant that we communicate our subject accurately to the general public. And that's ignoring all the other parts, like getting them to support and fund research and aid development and all those other kinds of areas. So my last few slides are going to be about communication itself. So one thing I'm going to be absolutely clear on is I do not think that we should be going out and telling the general public about science. Telling as in a one-way dialogue, a one-way stretch of communication. And let me give you an example that really clearly highlights this. Radioactive sheep. Okay, so this is a historic story and relates to 1986 when Chernobyl exploded, the nuclear reactor in Ukraine. And the impact it had on hilltop farmers who lived near the UK Sellafield power plant. So a snapshot history, more details available online if anybody's interested, is that not long after Chernobyl there were really heavy thunderstorms which travelled over the UK and this particular area where Sellafield was located. And what it did is it brought down cesium isotopes from Chernobyl onto the UK landscape. So scientists are very quick to dismiss that there would be any threat from these cesium isotopes in the rainfall. So they dismissed the threat. But it quickly became apparent that no, there were cesium levels present in the soils, but scientists assured the public, and when I say public here, I'm particularly focusing on the farming community in this area, that any effects would be very short, and after 3 effects, this cesium would degrade, would be removed. But after 6 weeks, actually, these levels hadn't gone, and there was a ban on movement of the animals on these farms, which is mostly sheep, and then there's a ban on them being slaughtered and put into the food chain. They still thought this would only be short term. However, after 3 weeks, this went to indefinitely, so no fixed end time. And of course, this has massive financial implication for the farmers. So risk of having to slaughter their animals with no financial return or small compensation, which could affect the farmers themselves, or having to sell the young lambs out of the affected area, presumably for a very reduced price, so they could be raised on non-cesium infected crops and be purged of the contamination before being sold on. So once again, financial loss. And just to give you a sense of scale, this affected 400 farms, massive farms, so a big impact. Scientists persisted that the cesium would erode and go away. But the reason I'm telling you this story is that scientists were adamant in their ways and they did not listen to or communicate in a dialogue with the general public. So, for starters, the scientists based all their calculations on alkaline soils, whereas many of the farmers in these affected areas actually had heavy acidic peat soils, which retained the cesium far longer. And actually put it back into the growing vegetation. So a simple dialogue with some of the farmers would solve this. Secondly, the scientists conducted a trial where they penned sheep in cesium-infected areas and non-cesium-infected areas as way of the illustration to reinforce the fact that these levels would decrease. But the farmers did tell them this is absolute nonsense because sheep aren't penned in. They roam massive areas, so they're not kept constrained in one areas. So levels of cesium are very different. Secondly, obviously they're in Sellafield. I mentioned that at the very beginning. And the farmers were very adamant that there's always been cesium in their fields because of Sellafield. There's no data to support this. Scientists thought that the cesium from Sellafield would be very different. So farmers actually took the initiative and took control, and they collected their own samples of soil from areas which were unaffected by the rainfall, but were affected by Sellafield, and got them analysed to prove the point that actually the contamination was a level different. So my whole point of this slide is to say that simply telling the general public what we know is never going to work. And this fits into my slide here, which shows the three main models by which we can communicate with the general public. The first one is called the deficit model, which is a historic model and not used anymore, at least in formal science communication strategy. And it's called the deficit model, as in, I know science, I love it, and I'm going to tell you what I know. You need to know these things. Here they are. In a way, this is the base of formal science education still today. These are the things that you need to know. And it's very, very complicated. Aside from the power complexes, what do you need to know in terms of subjects, and which parts of those subjects do you need to know? As our knowledge expands, it gets more and more powerful. And even more fundamental, do we need to know the subjects, or do we need to understand how the information came about? So by that I mean research methods, so people can go and find stuff themselves. And is it okay in education if someone knows nothing about geoscience but knows lots about physics, or vice versa? You know, what is the basic level? And even worse than the deficit model, how do we update it? Because things change incredibly rapidly. You know, once you've got the information, how do you keep the currency going? The second model is called the dialogue model. So this is based on two-way communication between scientists and the public, where ideas and information are shared. So this is a more useful approach where there's a discussion about things, but it still does have lots of problems depending on the circumstance. The dialogue model still can have a power complex, and there's always questions in these kind of models about what kind of influence the general public have. Are they just tokenistic, or do they generally have a chance, an opportunity to shape things, going back to the fracking and other policies we talked about? Nowadays, most people focus on what we call the participatory model, which is scientists and the public genuinely working together, where they are an invested collaborator in the process. And a classic example of this is the dialogue conference, where scientists and members of the general public work together on a key issue, let's just say fracking, where experts and the public give their views. They call in other scientists and members of the general public to give things, and they come up with a combined decision, which is then formulated and turned into policy or governmental advice. They work together. They're still not without their problem. They're very labour intensive. The kind of general public who these attract are very specific sub-demographics, often with vested interest in it. So they certainly don't reach all, but certainly much more like the approaches that we need to move. So in terms of science communication, there's really two parts of it. And the bit I was just talking about is what you can see in the white bubble here, the actual ways that we speak to people. And when I say speak, of course, I don't just mean speaking. I mean texting, typing, any form of communication in the general public, whether that's blogs, speeches, videos, infographics, or what, any forms of communication. The other side of it is the places where they get that information from. So the areas that I'm particularly interested in, which aren't reflective of all areas of science communication, include children's literature, books, computer games, TV shows, magazines, museums, charities. All of these places have geoscience material present in them. You maybe have never thought about it before, but you will see. You wouldn't have to look very hard in any of those areas to find places that people see geoscience. So I guess my final slide is a call to arms, really. Well, what can I do about this? Why should I care? Well, hopefully you do care now. What can I do about it? So I think at this early stage of your careers, I think two things. First of all is be aware. Okay, be aware. And a great place to start being aware is a journal. And this journal is called Geoscience Communication, which is a science communication journal for your discipline. All open access, includes a range of really interesting articles. So if you do nothing else from here, I'd advise you to take a look at this article and this journal and look at a couple of current articles. So being aware. Being aware also expands to when you watch a TV program or see a news story that relates to your subject, just think about what that may feel like to somebody who doesn't have your educational background? The second one is share. Share your passion and love for the subject. How do you do that? Well, a good place to start would be using outreach. So if you, for example, go to the Geological Society outreach, and there are many, many others, you'll see a whole range of ways you can do this. It could be as simple as writing a blog or an article or popping into your local primary or secondary school, and with consent, of course, to run a session and share on the things you know. Share that passion. Be aware, share. Anyway, that's the end of this presentation, and I hope you liked the introduction to science communication in geoscience.